In 1976, NASA sent a tiny laboratory to Mars to ask one question: is anything alive in this soil? Not fossilized, not long gone, alive. Something that might eat, react, breathe out a gas, or leave a chemical whisper inside the red dirt. And the unsettling part is this. One of Viking's experiments gave a signal that looked a little too much like yes, but NASA never announced life on Mars, because another instrument did not find what scientists expected to see. No clear organic molecules, no complete chain of evidence, no result strong enough to rewrite every biology textbook on Earth. So the story was filed under a careful phrase: no definitive evidence of life. But 50 years later, the old question is back. What if the Viking landers did not fail? What if they saw something real, but human beings did not yet understand Martian chemistry well enough to read the answer? This is not a story about NASA hiding aliens. It is stranger than that. It is a story about science asking the right question before it had the right tools to understand the reply. Go back to July 20, 1976. Exactly 7 years after Apollo 11 landed on the moon, human attention turned from the moon to the red planet. Viking 1 descended toward Mars. The signal confirming its landing had to travel across more than 200 million miles of space. People on Earth could not know instantly if the spacecraft had survived. They had to wait. They had to wait for a small radio signal crossing the emptiness between worlds. Then it arrived. Viking 1 was alive on Mars. It was the first successful American landing on the Martian surface. But the landing itself was only the beginning. Viking was not just a camera. It was not just a weather station. It was a biological laboratory. For the first time, humanity had placed a little science lab on another planet, scooped up alien soil, and asked directly, is there life in here? Think about the weight of that question. If the answer was yes, Earth would never feel the same again. Life would no longer be a local accident. Earth would no longer be the only known example. The universe might be full of tiny living things hidden in dirt, ice, rock, and chemical darkness. But if the answer was no, that would be almost as haunting. Mars once had water. Mars was once warmer. Mars once looked more Earth-like than it does today. If a world with that much promise was still empty, then Earth might be much more unusual than we like to imagine.
So Viking was not only exploring Mars, it was exploring human loneliness. The Viking landers carried a set of experiments designed to search for life from several angles. One instrument looked for organic compounds in Martian soil. Another watched for gases released after the soil was exposed to nutrients. Another added nutrient solution tagged with radioactive carbon, then waited to see whether anything in the soil would consume it and release a radioactive gas. The logic was simple. If microbes were living in the soil, feeding them might trigger a response. They might metabolize. They might release something. They might make the instrument twitch. And in the experiment known as the labeled release experiment, something did happen. After the nutrient solution was added, the instrument detected radioactive gas. It looked as if something in the soil had responded. Even more intriguing, when another soil sample was heated first and then tested the same way, the signal disappeared. On Earth, if heating a sample kills the response, that can sound very biological. Not proof, but enough to make the room feel different. Imagine the control room. Data is coming in from another planet. Not pictures of animals, not ruins, not a voice from an alien civilization. Just numbers, a graph, a small amount of gas inside a sealed experiment box. But interpreted one way, that gas could mean life on Mars. The problem is that science does not let us fall in love with one answer too quickly. Another Viking instrument was supposed to search for organic molecules. If life was present, scientists expected at least some carbon-based chemistry to show up, some residue, some organic trace, something that made the biologically looking result easier to trust. But that instrument did not find clear organic molecules, and this is where the story split in two. One path said, if there are no organics, there probably is no life. The labeled release signal must have been caused by reactive Martian soil chemistry. Maybe the soil contained powerful oxidants. Maybe water and nutrients triggered a chemical reaction that only looked alive. The other path said, wait, what if Martian soil is stranger than we thought? What if the very process used to search for organics was destroying the organics it was trying to detect? Decades later, Mars missions made one word unavoidable: perchlorate. Perchlorate salts were found in Martian soil by later missions.
They matter because when heated, they can react in ways that destroy organic compounds. Once you know that, the old Viking data starts to look different. If Viking heated Martian soil to search for organics, and if that soil contained perchlorates, then maybe the missing organics were not proof that organics were absent. Maybe they were destroyed during the test. That possibility reopened the old mystery. Some scientists have argued that Viking may have been closer to an answer than the official conclusion suggested. Some have even asked whether Viking detected signs of life, and humanity simply failed to recognize them. But the other side of the debate is just as important. Perchlorate does not only help the life-friendly interpretation, it can also help explain how Martian soil could produce strange reactions without biology at all. In other words, Martian chemistry can confuse us in both directions. It might destroy evidence of life, and it might create signals that imitate life. That is what makes this story so powerful. Not that it has an easy answer, but that it refuses to give us one. If we say Viking definitely found life, we go beyond the evidence. If we say Viking saw nothing interesting, we flatten one of the most fascinating scientific puzzles ever sent back from another world. The truth is more uncomfortable. Viking saw something real enough that scientists are still arguing about it 50 years later, but not clear enough to change history on the day it arrived. After Viking, Mars went quiet for a long time, not because humanity stopped caring, but because the life question had become heavy. If you send a spacecraft to ask directly whether life exists, and the answer comes back ambiguous, what do you do next? NASA gradually changed its approach. Instead of asking, is there life right now? Later missions asked a more patient question. Was Mars ever habitable? Was there water? Were there minerals formed in water? Were there organic molecules? Were there rocks that could preserve the traces of ancient microbes? This became the logic of follow the water. Find the water first, because on Earth, wherever there is water, life is very good at finding a way in. Mission by mission, the picture of Mars changed. Pathfinder, Spirit, Opportunity, Curiosity, Perseverance. One rover, one rock, one layer of sediment at a time. The dead red planet began to reveal a wetter, warmer, more complicated past. Curiosity found organic molecules in Martian rock. NASA has been careful to say scientists do not know whether these molecules came from biological or geological processes. Either is possible, but the discovery still matters. It confirmed that ancient Mars had chemistry that could support life. Then Perseverance added another layer to the mystery. In a sample called Sapphire Canyon, taken from a rock known as Chayava Falls, NASA reported potential biosignatures. That phrase is very important. A potential biosignature does not mean life has been found. It means a substance or structure might have a biological origin, but more data and more study are needed before anyone can conclude whether life was involved. It is a clue, not a verdict. But place that clue beside Viking, and the old story changes shape. In 1976, a lander saw a reaction that looked biological, while another instrument failed to find clear organics. Decades later, we learned that Martian soil chemistry may make those old tests more complicated than anyone understood at the time. And today, newer rovers have found organic molecules and potential biosignatures in ancient environments shaped by water. None of this proves Viking found life, but it makes the old question hard to bury. It is like a cold case, not closed because the mystery was solved, closed because the evidence was not enough. Then new tools arrive. You reopen the file. You look at the same fingerprints, the same fibers, the same witness statements, but now you understand the scene differently. Suddenly, what once looked like noise may have been a clue. This is why Viking still matters. It is not just an old spacecraft. It is a mirror for how humans search for truth. We like to imagine science as a straight line. Ask a question, run an experiment, get an answer, move on. But real science is messier. Sometimes you ask the right question with the wrong instrument. Sometimes the data is real, but the context is missing. Sometimes you are not wrong. You are early.
Viking may have been one of those moments. Maybe it didn't find life. Maybe it touched the edge of something that still has not been fully understood. We do not know. And that phrase, "we do not know," is not a failure. In science, it is fuel. It is why we send the next rover, drill the next rock, collect the next sample, build the next instrument.
It is why scientists want pieces of Mars brought back to Earth, where laboratories can study them with tools far more powerful than anything we can land on the planet. If one day a Martian sample is returned to Earth and scientists find clear evidence of ancient life, Viking will be seen differently, not as a mission that failed, but as a mission that arrived before its time, a spacecraft that knocked on the door of one of humanity's biggest questions half a century too early. And if we eventually learn that Mars never had life at all, Viking still matters, because it taught us that not finding life can be just as complicated as finding it. You have to know what your instruments can see, what they cannot see, which chemicals might destroy evidence, which reactions might mimic biology, and which questions need to be asked again in the language of a new generation. So did NASA already find life on Mars? We do not know. But maybe the deeper question is this: if the universe whispered an answer to us once, were we ready to understand it? Viking may not have given humanity the final answer, but it did something almost as important. It showed us that the search for life beyond Earth may not begin with a creature walking past a camera. It may begin with a handful of red soil, a small amount of gas inside a sealed box, a graph rising on a screen, and a control room on Earth going quiet for a moment, because everyone in that room understands what it would mean if that graph was alive. 50 years later, we still do not know exactly what Viking was trying to tell us, but that may be why the story is not over. Not because NASA has a secret, because Mars still does. And sometimes the biggest secret in the universe may not be hidden in a distant galaxy. It may have been sitting inside one handful of red Martian soil since 1976.